Alright, so we are going to discuss combining all of our factoring methods together and using several methods in one problem. So in order to figure out what method do I use when, and how do I know, I have given you all a copy of this flow chart. So 100% of the time when you approach any problem, and we're going to do 5 problems here in a minute, but 100% of the time when you approach any problem, you are going to factor out the GCF first. So when you factor out the GCF, it's going to go out in front of parentheses, and then look inside those parentheses and ask yourself the next following questions. Is what's inside parentheses a binomial, a trinomial, or a polynomial? If it's a binomial, the only binomial that you know how to factor is the difference of two squares. If it is, this is your factor pattern, that plus minus pattern. That's what the difference of two squares looks like, right? And so it factors looking like this. If it's not, D2S is difference of two squares. If it's not the difference of two squares, it's not factorable and you're done. All you could take out was the GCF. So if it's a trinomial, you're hoping it's a perfect square trinomial because they have a pattern that's easy to factor, and here it is right here. If it's not a perfect square trinomial, it doesn't mean it's not factorable. You just have to treat it as a regular trinomial, and now we're looking in terms of the standard form, ax squared plus bx plus c. You just need to use the t-chart and then use your grouping. If it's a polynomial of 4 or more terms, get my pointer out here, and you're only going to have 4 terms, you're just going to factor it by grouping, and that's it. So let's see how that works in the next following 5 problems. So for example 1, again, I'm just going to go through the questions on that flow chart that we just went over. So the very first question is there a GCF? So as you look at the problem, there may or may not be a GCF. Whoops, here we go, here we go, here we go. So as we look at the problem, you can see that the very first term is negative. I don't know, my pointer is being very slow today. Why is it not popping up? Hang on, let me see if I can fix something. Alright, so my iPad is trying to install a bunch of stuff while I'm here at school, so that's why my pointer is being very slow. So I'll just try to do my best. So anyway, the first term here is negative. So anytime that first term is negative, you've got to factor out a negative. So we're going to factor out a negative from each one of these. Then look at each of the numbers. As you look at the numbers 2, 16, and 32, 2 being the smallest, it does divide into 16 and 32. So we are going to factor out a negative 2 from each one, and then look at the variables. Since they all have an x, we're going to factor out an x, but they do not all have a y. So this one here doesn't have a y, so we're not going to factor out a y. So we're going to add the x to that. And you're going to bring that greatest common factor out in front of parentheses, and then you're going to perform the division. So the negative 2 divided by negative 2 cancels out. The x over x cancels out, and you're going to bring down the y squared. Then 16 divided by negative 2 is negative 8. Make that bigger. And then the x's cancel out, and you are going to bring down the y. Finally, negative 32 divided by negative 2 is going to be a positive 16, and the x's cancel out. So then we have to look at the next question on that flow chart. The next question says, is this in here a binomial, a trinomial, or a polynomial? Since it's got 3 terms, it's a trinomial. We're hoping it's a perfect square trinomial because then we can use the pattern. So because I've got a perfect square here, because this is even, and 16 is a perfect square, we're going to test it. So in order to test it, let me find the square root of y squared is y, and the square root of 16 is 4. And I want to apply my test. My test is 2 times a times b. So 2 times a we found was y, and b we found was 4. And so the answer to that, 2 times y times 4, is 8y, and that matches. So I'm going to put, my iPad will cooperate. There we go. I'm going to put, well, hang on. Again, it's being slow. One more time. Yes. Oh, there we go. All right, so it does match, which means it is a perfect square trinomial. So I'm going to finish my answer up here. You always have to keep bringing down that greatest common factor right here that we brought out originally. So I'm going to start with that out in front, then negative 2x. But then as soon as I have determined right here that it matched and it was a perfect square trinomial, immediately I know that that trinomial is going to factor into one set of parentheses squared. And then each part of this trinomial is going to contribute something to this factoring. So the y squared is going to contribute the y. So let me put that in there. Clearly, that wasn't what I wanted. Oh, technology. So it's going to contribute the y. And then the middle term here, the 8y, is going to contribute the negative sign. Middle term contributes the sign. And then the 16 is going to contribute the 4. So then you have to make sure that you look inside the parentheses to make sure you don't have anything further. And so since this is a binomial, and the only binomial that you can factor is the difference of two perfect squares, you do have a difference, and the 4 is a perfect square, but the y is not. So since that's not the case, you don't have the difference of two perfect squares, this is it. This is your final answer. Done. So let's go on to example 2. So for example 2, we're going to run through the same questions. As I look at the problem here, the very first question 100% of the time is what is the greatest common factor? So as I look at 3, 15, and 12, 3 is the smallest number. So I want to start there. Since 3 divides into both 15 and 12, it is going to be our greatest common factor. And I'm not dividing by negative this time because the first term is not negative, so I don't need to. So each one of these get divided by 3. Then look at your variables. I've got n to the 4th, n cubed, and n squared. So they all share an n. And the most n's that they share is the smallest amount here, the n squared. So then don't forget to bring that greatest common factor out in front of parentheses and then perform your division. So 3 divided by 3 cancels. Don't forget when you divide a power, you're going to take 4 of these and subtract 2 of these. We subtract the exponents. So 4 minus 2 is 2. So we end up with just an n squared. And then 15, or negative 15 divided by 3 is negative 5. And then 3 of these minus 2 of those is going to give us 1n. And then 12 divided by 3 is 4. And the n squareds cancel. So you need to look at what's left in the parentheses and follow your flow chart. The next question on the flow chart is, do you have a binomial, a trinomial, or a polynomial? Since you have 3 terms, we have a trinomial. We are hoping it is a perfect square trinomial. So we are going to test it. My bookends are both positive. So let's take the square roots and see if they're perfect squares. So the square root of n squared is n. The square root of 4 is 2. And my test, remember, is 2 times a times b. That's the last test we apply. So 2 times our a is n and our b is 2. And so 2 times n times 2 is 4n. And you want to compare that to your middle term. No, it does not match. That's a no. No, it doesn't match. So that just means it's not a perfect square trinomial. That doesn't mean it's not factorable. It's just not a perfect square trinomial. So we have to then look at the next question. We have to treat it as if it's a regular trinomial, which means we're going to use our t-chart and we're going to use grouping. So your a, be really careful, your a here is the coefficient of the n squared term. So since there's no number in front, that's 1, and your c is 4. So 1 times 4, oh, gotta love technology, there we go, gives us a positive 4. Our b is our middle term, so that's negative 5. And our first factors of 4 would be 1 and 4. They add to give us 5, and there it is. So I can just stop. Let's figure out our signs. So the sign of the 5 is negative. So think through your other signs. If you have to have a positive product and you're in the addition column, the only way you can add two numbers is if they have the same sign. And so if this is negative, the bigger these two always carries the same sign. So the 4 is also going to have a negative. Because they have to have the same sign, the 1 is also negative. So then we are going to replace that middle term, negative 5n, with the two new middle terms. So we are going to replace the 5n here with these two. Don't forget to bring down the 3n squared. And then I'm going to use brackets here, and I'm going to rewrite, I'm going to bring down that original n squared, but instead of this negative 5n here, I'm replacing it with these two. So I'm going to have a minus 1n and a minus 4n, and then bring down the other bookend of plus 4. So now we have to group them. So cut that in half. Find your GCF of the first group. So for this group, they have only an n in common. So then that n is going to get brought out in front of parentheses. Perform your division. N squared divided by n is n. And then these n's cancel, so you're left with, well, let's back that one up. That didn't work out. So you're left with this negative 1. So minus 1. Then look at your next grouping. Because this third term here is negative, we have to factor out a negative because we always want this one and this one to be positive. So because of this negative, factor out a negative 4 because that's what they have in common. Bring that out in front, and then perform your division. The negative 4's cancel, you're left with an n. Positive 4 divided by negative 4 is a minus 1. And you see that what you have in parentheses is identical, which is what you're looking for. I'm going to add in some brackets because I cannot forget to bring down that original greatest common factor of 3n squared. So now we're ready to write our final answer, so I'm going to put it over here. What they have in common is in n minus 1. Now let me move that over a little bit. Okay, so they have in common in n minus 1. So I'm going to bring that out in front of parentheses. And then what's left over in front, here and here, goes in the empty parentheses over here. So we've got n minus 4. And then, of course, don't forget to put in front there we go, 3n squared. And as you look at your parentheses now, this is a binomial, and it is a difference, but it's not a difference of two perfect squares. Although one is a perfect square, n to the first is not, because it's got an odd exponent. This is a difference, and that is a perfect square, but again, n to the first is not. So we are done. We cannot factor anything else on this polynomial further. So there you go. Next problem. For example 3, again, we're going to follow with the very first question, is there a greatest common factor? And as you look at the numbers 4, 18, and 20, 4 is the smallest, but although it divides into 20, it does not divide into 18. So the other numbers that divide into 4 would be 2, and fortunately 2 does divide into both of those. So your greatest common factor as far as your numbers are concerned would be 2. And when you look at your variables, they all have an x in common, and the most x's they have in common is this one because it's the smallest one. And so we're going to add an x here and bring that 2x out in front of parentheses and perform the division. So 4 divided by 2 is 2. X cubed divided by x is x squared. We are subtracting exponents. 18 divided by 2 is 9. X squared divided by x is x. 20 divided by 2 is 10. And these x's cancel out. So then we need to look at what's left in parentheses and factor this. So the next question, is it a binomial, a trinomial, or a polynomial? It is a trinomial. You're hoping that it is a perfect square trinomial, but because 2 and 10 are not perfect squares, sorry, Kalijah's being really noisy, we cannot factor it as a perfect square trinomial. So instead we have to treat it as if it is a regular trinomial, and we are going to use a t-chart. So here's my t-chart with a times c and b and our plus minus. And so our a is 2, our c is 10, 2 times 10 is positive 20, b is our middle term, positive 9. So your factors of 20 are 1 and 20. They add to give you 21 and subtract to give you 19. The next factor is 2. That would be times 10. Add, you get 12, and subtract, you get 8. Keep going. Next factor is 3. 3 does not divide into 20. Next factor is 4. 4 times 5 is 20. Add them, you get 9, and there is your middle term. Slowing down there. Whoop. There we go, finally. So your 9 is positive. So again, use your brain. If there are no negatives in this problem, there cannot be any negatives here. So since the 9 is positive, and the bigger of these two carries the same sign, the 5 is going to be positive, and the 4 also has to be positive in order for there to be that positive product. So they're all positive. We're going to add in our x as our variable, and we're going to replace this middle term right here with a positive 4x and a positive 5x. Bring down the 10 and the 2x squared, and don't forget to bring down the original GCF of 2x. So then we need to cut this in half, and find the GCF of each group. So the first GCF here would be 2x. Take that out in front of parentheses and perform your division. So the 2's cancel. X squared divided by x is x. 4 divided by 2 is 2, and those x's cancel. The next group have a 5 in common, so we're going to pull out in front a positive 5. Perform your division. The 5's cancel, bring down the x. 10 divided by 5 is 2. And of course, don't forget, I'm going to add the brackets, and I'm going to bring down my original greatest common factor of 2x. So now for the final answer, they have an x plus 2 in common, so you're going to bring that out in front of parentheses. And then what's left in front, the 2x and the 5 are going to go here in the empty parentheses. And of course, don't forget to bring down the original 2x. Then look inside your parentheses. This is a sum. It's a binomial with a sum. You cannot factor a binomial with a sum. This is also a sum, so same thing. You can't factor that. So as a result, you are finished. This is your final answer. All right, example 4. So for example 4, it looks like it's going to be easier, but I like to title this my Energizer Bunny problem, and you'll see why. So if you know anything about the Energizer Bunny, he's that cute little pink rabbit who runs around with his little bass drum and, oh, hang on. All right, sorry. Internet's giving me problems again. All right, so the Energizer Bunny is a bunny who's hitting his little bass drum. His little ears are hitting too, and basically the whole goal is that he keeps going and going and going. And so what I mean by that is, let's go back and look at a simple problem, 32. We had asked you previously to prime factor 32. So we're going to take 32 and break it down into 2 smaller pieces. And you can choose whatever you want to, 2 and 16, 4 and 8. I'm going to choose 4 and 8. 4 is not prime, so it can be broken down even smaller, so it keeps going. 4 can get broken down into 2 and 2. Since 2 and 2 are prime, we stop there, we're done. But 8 can keep going. It gets broken down into 2 and 4. 2 is prime, so that one stops, but the 4 can keep going. It gets broken down into 2 and 2, and finally we're completely done and stop. Energizer Bunny's dead. So as you look at a problem like number 4, the greatest common factor is always your first question. So we're going to factor that out first. These have a p in common. So we're going to divide them both by 1p and bring that p out in front of parentheses and perform your division. So p to the 5th, take away a p, gives you p to the 4th, minus, when those p's cancel, you're not left with nothing. Anything divided by itself is 1. So then we have to look inside the parentheses and see if you can factor that further. We have a binomial. The only binomial we can factor is the difference of 2 perfect squares. So are these 2 perfect squares? Well, this p to the 4th is because 4 is an even exponent. So any variable raised to an even exponent is always a perfect square. A lot of you like to say that 1 is not a perfect square, but it is, because 1 times 1 is 1. So the square root of 1 is 1. So if I take the square roots of each of these, square root of p to the 4th, that would be p squared, because remember, the index here is 2. So we divide this by 2, and that's how we got the 2. Then the square root of 1 is 1. So I'm still going to bring that greatest common factor, the p, out front, but this binomial gets replaced with 2 parentheses, that plus minus pattern. So it gets replaced with parentheses plus minus. So this whole thing here is going to get replaced. You can think of it as branches, just like over here, the 32 is getting replaced by 2 things, a 4 and an 8. Well, this is getting replaced by 2 things right here. Let me put those in there. Bloop, bloop. There's your 2 branches. And we're going to put in there our square roots. So p squared goes here, and 1 goes here. P squared here, and 1 goes there. So then we need to look in each of our parentheses. Are we done here? Well, this is a binomial, and it's a sum, so you cannot factor the sum in a binomial. So we're done here. We'll look over here. We have a difference. This is a perfect square because we have an even exponent, and again, remember, 1 is a perfect square. So all of this is getting brought down. Don't leave it. So I'm going to write it exactly as you see it, p, and then parentheses with a plus, and then the p squared plus 1. All right, so then this right here is going to get replaced with its difference of 2 square factor pattern, which is a plus minus pattern. So in order to figure out what goes here, you have to take the square root of each of these. So remember, the square root of p squared is p. So we're going to put a p here and a p here. And the square root of 1 is 1. Then finally, look to see, are you done? This is a binomial, and it's a plus, so you cannot factor the sum in a binomial. This is a binomial with a difference. You can factor the difference of 2 squares, and 1 is a perfect square, but p to the first is not, because an exponent of 1 is odd. So finally, we have reached our final answer, which is all of this. Done. Last problem. Example 5. So again, go through your questions. First question, is there a greatest common factor? Look at 3, 7, and 4. 3 is the smallest, and it does not divide into either of these, so there is no number that's a greatest common factor. And they do not all share an x. 4 doesn't have one, so there is no greatest common factor. So the next question is it a binomial, a trinomial, or a polynomial? Since it's a trinomial, we need to test it. Is it a perfect square trinomial? Well, 4 is a perfect square, but the 3 is not. It kind of kills it. So that doesn't mean it's not factorable, remember? Just means we're going to treat it as a regular trinomial, and we're going to use our t-chart, a times c, our b, and our plus minus. So our a here is 3, our c is 4, 3 times 4 is positive 12, and our b is positive 7. So our factors of 12 would be 1 and 12, add to give us 13, and subtract to give us 11, none of which are a middle term. Next factor is 2. 2 times 6 is 12, add we get 8, subtract we get 4, still not a middle term. Next factor is 3. 3 times 4 is 12. We add, we get 7, and there it is. So we're going to use those numbers. And again, use your brain. Notice how there are no negatives here, so there cannot be any negatives here. And 7's positive. We have a positive product, which means we have to have the same signs. We're adding in the addition column, which means we have to have the same signs. So all the signs have to be positive. Add in your variable of x, and we are going to replace that 7x with a positive 3x and a positive 4x. Bring down your 3x squared and your positive 4. Then continue, group them, take out their GCFs. So the GCF of the first group is 3x. bring that out in front. Do your division, the 3's cancel, x squared divided by x is x. The 3's and the x's cancel, which means you're left with 1, not nothing. And then your GCF in the second group is 4. So bring a plus 4 out in front and do your division. The 4's cancel, bring down the x, the 4's cancel, and you're left with 1. And as you can see, you have the same thing in both of these parentheses. So the x plus 1 comes out in front. And then what's left over, the 3x and the 4, go into the empty parentheses behind. And then you just want to quickly evaluate, are you done? We have two binomials, both of which are sums, so that should tell you, since they're sums, you cannot factor the sum of a binomial other than a greatest common factor, and we've already tried to take that out. So there is our final answer. Last but not least, this is your homework assignment. Multiples of 3 mean you're going every third problem. So 3, 6, 9, 12, 15, and 18. Have fun. Have a great day.